I'll start. I'm presenting a particular specific paper with Larry Samuelson of Yale. When I was younger, I had a tendency to start by saying what drives me and then present the paper, and then the audience and even more so my co-authors were upset that I'm overselling. So with age, I developed this strategy of doing it the other way around. I present the very minor result, and then I'll do the wild overselling and tell you why it's so important and going to change humanity's future with your help. But let me start with the paper. So what is it about? Oops, sorry, I think this works this way. So let us imagine, we'd like to think of a scenario in which we have a decision maker who could think about someone who makes decisions for us, the government office of one sort or another. It could be someone who invests our money, the fund manager or something like that. We require them to have some kind of a protocol, give an account of the decision they made using decision theory. Okay, so what were you thinking kind of question is what we want to ask them when the time comes, and often this would happen when the result is not so exciting. We'll go back and say, what exactly did you have in mind when you made this decision on my behalf, for me, or something along these lines? Actually, we do think of this also as something that a decision maker or makers working together would like to ask themselves, such as, why am I going in this direction? Am I prone to some of the errors and biases that I heard about from the psychological studies, starting with Hyneman, Tversky and their followers? Are my beliefs a little bit weird in terms of the probabilities I assign to various events? Maybe my utility is not exactly what I would like it to be, etc. So this is a bit broader than what we do here, because in this project we actually assume a given utility. But two things that one can sort of bear in mind are questions of just a fund manager who's investing money for others. And you might come back and ask them, okay, what did you have in mind? What kind of beliefs did you have in mind when you thought that this was a good investment? And that'll be a case in which the utility is more or less given. We basically equate it with money, plus or minus. You could have some risk aversion, but basically it's clear how to quantify it up to some parameters. A more difficult one would be a situation such as COVID, when governments make decisions on our behalf, and lockdowns, no lockdowns, vaccinations or not, etc. There, the utility is not as obvious, but in this paper, we'll assume that the utility is there. So I'd like you to sort of keep in mind that what we're doing is probably not the complete answer to the kind of question we want to ask. But generally, that's the idea. So here we're going to make the following assumptions. We're going to assume that the possible outcomes and the utility functions are known. We will also assume that the states of the world are known. So the big issues of unawareness and questions that you're not aware of what could happen, we sort of set aside. So we really focus on the question of probability and or uncertainty, and this is where this would tie in with the meeting's main topic. We will ask the question in the Bayesian benchmark, when one has their beliefs given by a single probability measure. And later on, we'll move on to at least one model of ambiguity aversion. Just 2 words. The word ambiguity is sort of taken over in economics for Knightian uncertainty. I was less fond of it. I think that Ellsberg, who presented very nice mind experiments that sort of are cited a lot, where many people's intuitive answers are not Bayesian. I think he was the first to use ambiguity. There was even a time, I don't know, maybe 2 decades ago, where I was trying to say that we should not use ambiguity, not because I had anything against Ellsberg, but just because ambiguity in other fields means a lot more. I mean, think about both law and psychology. Ambiguity typically refers to multiple interpretations. something that I fear we don't do enough in economics. We don't formally deal with interpretations in formal models almost at all. Anyway, I lost that fight. So just in terms of the terms, most economists, economic theorists refer today to ambiguity when they mean night and uncertainty. So it really means only we don't know what the probability is. So it's basically equivalent. And ambiguity in the terms of multiple interpretations as we have of natural language or cues in psychology or something like this is largely neglected in economic theory. So anyway, this is the two terms here. So Bayesian would be, say, ambiguity neutral. Bayesian meaning someone who behaves as if he or she have subjective probabilities and they maximize expected utility relative to that, a la Savage with history in Ramsey, De Finetti, but Savage is the key result or the most convincing result to most economic theorists. The non-Bayesian approaches are approaches that say, well, maybe, I don't know exactly which axiom of Savage I'm not so excited about, but maybe something goes wrong in this story and maybe we don't have a single probability. In two words about the state of the art, I think that over the years, many economists do believe that descriptively, maybe one should look beyond the Bayesian framework. So especially with behavioral economics and things like this, economists agree that people can sometimes do things that are considered to be really irrational. Then many economic theorists would say, okay, among these irrationalities, they might even behave in a non-Bayesian way, namely make decisions in such a way that you cannot find a single probability measure that justifies this decision given expected utility maximization. Some people, including some of my co-authors and myself, also argue that normatively this is not, the Bayesian approach is not so compelling. And there are issues about this when you look at, in particular, Savage, the axiomatization that looks so pretty and so wonderfully convincing that one has to scratch one's head and ask, wait a minute, why? How come I think that it could possibly be rational to violate it? And you know, the long philosophical discussions about this that I will not get into right now. So the Bayesian framework is still considered, I think, by most economic theorists as the standard of rationality following Savage's axiomatization. Any questions? None? Okay. 2 words about related literature. So I'll say maybe 1 word now. This is a word, as you can see, and then 1 word after the presentation of the first result. There is a literature in economics that's called revealed preference theory, which basically asks a very similar question to the question that we ask. The question where I think the most prominent result is Efriat theorem asks, well, if you observe some decisions by, say, a household, could you possibly find a model that explains it within a certain framework? So in Efriat's case, there's no uncertainty. You just see a household making decisions under various budget constraints. You have finitely many decisions as if it were a real database. And the question is, does there exist a utility function that can rationalize these decisions? And then there's some nice results about it in Efriat's case. So there are conditions about the existence of a certain model, but the focus is not, as in the axiomatic approach, on assuming that you can make many decisions, observe many choices, and find a unique utility, probability, what have you. Here the question is more of when can the data be explained by one of the models in this family of models. And technically, that's the same kind of question that we ask here. Okay, so the question that we ask here, we'll put it in the formulas in a few seconds, but the basic question is, okay, you had someone who made decisions, say, government official made decisions for you, and now the question is, can they justify it? Where part of the rules of this game should be, what does justification mean? So we would say, oh, they can pull out a decision theoretic model and say, you see, with these parameters, this is what I had in mind. These are the best the choices I made were the best decisions that were available given these parameters. And I do have a model in this family, where in our case, the family would be once the Bayesian and once something else. So technically, it's the same kind of question because we observe a set of decisions which is finite and can be even very small. And these are presumably the decisions that were really made by this person or body. And then you ask, does there exist a model in a given family that can justify those? So it's technically the same kind of question that the revealed preference theory asks. However, the emphasis is a little different. And there are two main differences here between what the revealed preference theory does and what we do. The first is they're actually related. The first is that the revealed preference theory is actually a question about the work of the economist, not about reality. Okay, so we have, say, households that make decisions out there, and then you say, okay, here's an economist who's trying to fit the data, and they look in a certain family of models, say utility maximization, and they ask, can I find the utility function in this class that fits the data? Now comes the theorist who does revealed preference theory and writes down a theorem that says, when will this economist be able to accomplish this task? Okay, so there's a working economist who actually tries to explain data, and there is the, whatever you want to call them, theorist, philosopher, whatever, but there is someone there who takes the economist as their reality, and they're trying to model that. And they ask, when will this economist succeed in this particular task? So it's a mathematical theorem about the work, not of the economy, not about the, I'm sorry, not the work of the economy, but about the work of the economist. Okay, so it's sort of second order. You ask yourself as a theorist, or if you like, philosopher of science, a question where the data you're trying to explain are not economic data, but the work of an economist herself. By contrast, what we do here is actually first order. So what we have in mind is an actual decision maker, and we think about the actual decisions. So the audience of this paper, if you wish, is not the working economist, but the actual decision maker. So a lot of theory, a lot of what's called foundational theory is actually second order, impossibility results that error was mentioned earlier. Here our interpretation of the exercise is actually first order. And relatedly, it's a lot more normative. Okay, so it's when the working economist is trying to look at actual data sets and say, does there exist a model in this family of models that can explain this particular data set? They're taking the actual data set as descriptive data. This is what households did. Now let's see if we can explain it. In our case, the interpretation is a lot more normative. So the idea in the background is that there might be better or worse decisions. If people make decisions for us, we'd like them to make better decisions. And that's the general mindset. So this would make have some implications about the kind of data that we assume. I will not have too much time. I just mentioned here a couple of results that are sort of closer to what we do by Paulson, Kwan, Renaud, and by Chambers, Echenique, and Saito, but probably move on. Okay, so the framework we have in mind is a set of states of the world. As I said, we assume it's known, and we will also assume here it's finite. So lowercase s is the index of the state. There are acts. Again, we'll assume them to be finite. And each act yields a utility. So the thing in which this paper is very specific is in this, mostly, I think, is in assuming utilities as given. And so XAS is, if you like, think about this financial problem. That's the amount of money that you get, make, or lose in case that you chose A and you got in state S obtained. A big assumption here in terms of what is observable is that we're going to assume that the decision maker who's rationalizing their choice or choices, they have to write down in the protocol what was the decision they took. So what action A they took out of a matrix of possible actions. Okay, so let's say each choice is a row, so a very simple decision matrix. But they also have to say which certainty equivalent, which number C for certainty equivalent of A corresponds to each choice. So they have to write these down and show to you that they pick an act with the highest CA. Okay, so that's part of the rules of the game. In many situations in real life, you could say this is maybe unrealistic to assume it exists, if you were to take, say, the more descriptive approach. But here we're sort of playing the game that we are writing the rules of the game. We are going to let people make decisions for us, but we want them to write down these kind of protocols. We want them to specifically say at the end of the meeting why they decided on this or on that, and what they have to say is how they evaluated each one of the acts, where implicit in the story is that they picked one with the highest CA. Okay. So this is what we mean by can it be justified? The collection XA is given, so that's a matrix of the payoffs of the possible acts, and the decision maker needs to be able to attach a CA to each one of those. Okay. Now, what do we mean by justified? Well, there are two justifications. So the first one, the benchmark, the basically known results about Bayesian justification, and then we'll move on to a model which is non-Bayesian and uses specifically the max mean. So what's a Bayesian justification? Bayesian justification just says, well, here are the acts. This is the matrix of payoffs. Okay, and then the decision maker assigned to each row in the matrix a number at the end. And the question is, does there exist a single probability vector such that the expected payoff of each one of the rows is this given number, CA? Okay, so we call it Bayesian because here the decision maker says, well, I knew what my beliefs were. These beliefs could be subjective, but these were my beliefs. Okay, so I asked the fund manager, what did you have in mind when you made this kind of investment? And they say, well, I assigned this probability to that and this, etc. And with these probabilities, you see this is the source of my evaluations. And of course, you know, in reality, there will be some beliefs that are more likely than others. And we mentioned being paranoid at the beginning. Of course, here we don't say anything about that. So we leave it as something which is external to the theory. Here the question is, does there exist a probability vector without quantifying it too much? Though one can add a little bit of, some constraints could be easily added here if you want to make sure that the beliefs are not completely crazy. Okay, so this is what we call a Bayesian justification. And this first result says, well, this will exist if and only if the following condition holds. Actually, it's the same condition written twice. I'll explain why in a second. So the condition is to say there exists no collection of real numbers, which will be positive or negative, such that when you take the linear combination of the certainty equivalents, it is dominated by the linear combination of these vectors. Here, when you say CA was a number, here I mean the constant vector that has CA throughout. Okay. So since the coefficients here lambda are not constrained to be either positive or negative, what's written here is equivalent. Okay, we could this or that, of course, is the same because we can reverse them, but because of we want to generalize this in a bit, then we put both of them here. Okay, so before we move on, we should say the second word about related literature, that this is very, very close, if not identical, to what's called the fundamental theorem of finance. Fundamental theorem of finance basically says, well, let's say these X's are financial assets, so they yield a certain payoff, positive or negative, given different states of the world. And the price in which the asset is traded is the certainty equivalent. And the question is, when we get it, and the answer is that if there is no arbitrage, okay, so basically what this is saying is that there is no way to no arbitrage opportunities. You cannot have some kind of a mix or some kind of a linear combination of the assets such that the linear combination is definitely surely above or below the corresponding combination of the prices. Okay, so these are basically no arbitrage conditions. And the result that comes in the fundamental theorem of finance is that no arbitrage would exist if and only if there is a probability vector such that the assets are priced at their expected value. The direction is sort of the other way around, in the sense that if you think in terms of the fundamental theorem of finance, then you probably start with no arbitrage as your condition, equilibrium condition, because possibilities of arbitrage don't seem to make sense at equilibrium. And then you say, aha, Prof says, how we can have a way to explain what are the prices of expected values given some kind of market belief. For us, the direction was sort of the other way around, namely asking when there exists such a probability, and lo and behold, the answer is there's no arbitrage. Given that both are if and only if conditions, this shouldn't come as a major surprise, but the motivation is different. And as we go to the non-Bayesian model, this thing would break down. So that's why I put this kind of related literature after the proposition, because it's a bit of a coincidence that it's the same result. Technically, the fundamental theorem of finance usually is stated slightly differently, but it's basically the same, up to strict weak inequalities that we don't have to focus on. Okay. I'll briefly say that we'd like to think about it as kind of a debate game. Just imagine, I'll go back to the theorem for a second. So imagine that it's a two-person zero-sum game. And by the way, a simple proof of the result is to think about it in terms of a max-min theorem. I, as the person who has to justify the decision maker, I have to come up with a probability. If I manage to find a probability that justifies all my choices, all my assignments, then of certainty equivalence, then I win. You come to challenge me and you try to tell me that what I've done doesn't make sense, and the way to say it doesn't make sense is to find some kind of combination such that you say what you've valued this by is below the values. This is the double inequality here means each and every state, strict inequality at each and every state. So clearly you could show me that what I've done is silly if you have just one asset at which I priced it below its minimal price, or alternatively above its max price. Evidently doesn't make sense. Here we allow you to win the game if you can show some combination of assets in which what I've done doesn't make sense. And what the theorem says is that this is the same game. Okay, so the game in which the player one can win if she can point to a probability that justifies everything. At the same time, then all their XA's assignments simultaneously, then this is the same game as the game in which the skeptic who's trying to challenge her can show that she did something wrong or silly or foolish. Okay. The geometric interpretation is sort of cute. So before, as we're going to burn down all math at the end of this meeting, so just before this, along the lines of the previous talk, I'll also say why it's cute. Of course, what we say here is not new in any way or shape, but it's still very nice. In the two-state case is very special in the sense that basically we have only one parameter. So if we have two decisions that are coherent, then they point down the probability vector completely. And this also means that we could, if you want to see if a set of decisions, set of assignments is coherent, it's enough to check just pairs. So in some sense, it's a little too special, but it's still cute to see that it's basically triangle similarity. Not sure I have time to go over all of these. I'll just mention briefly one thing that we will allow in the next result is what you see here on the left panel. Left panel, you suppose that your decision maker evaluates this x1, 1 and 0 at 0.4 and 0, 1 also at 0.4. And then you say, aha, but you could mix them and generate 0.5, and 0.5 is better than this 0.4. And this is something that would be, of course, not allowed by the Bayesian approach, but soon enough we will allow it in the non-Bayesian one. Beyond that, it's just sort of nice to see that this is basically no more than Taylor's theorem, that one triangle is similar to another if and only if these lines are parallel, and to say that you have the same probability that justifies this assignment of certainty equivalent and that assignment of certainty equivalent is just to say that these two segments are parallel, which is basically Taylor's theorem. These two segments are parallel if and only if these things are proportional. And basically the same thing would hold here, but maybe I should move on. Okay, just briefly to mention De Finetti, who worked in parallel to Ramsey, but also believed in subjective probabilities and also provided very convincing reasons as to why you are irrational if you're not assigning subjective probabilities. We usually teach him as discussing the case that we have here of risk neutrality, or knowing what the payoff is, basically deriving expected value maximization, assuming that you know what the utility function is, relative to some subjective probability. Excuse me. So, and De Finetti's case was, again, say you have states of the world that are given, and he divided the bets to acceptable and unacceptable, and showed that with some convexity, or even mentioned that with some convexity you could find a separating hyperplane, and that separating hyperplane, the normal to this thing, is what we call your subjective probability. So the idea is also in Ramsey, also in Borel, this idea of saying subjective probability is this kind of thing that governs your betting behavior, and if you make decisions in a coherent, rational way, we could think of you as if you have these beliefs. Relative to what De Finetti did, then what we do here is more along the lines of the revealed preference paradigm, in the sense that there are finitely many decisions that you actually have made, and these are those that you have to justify. So it's not like asking about all the hypothetical choices that you might ever encounter. So it's not along the lines of axiomatization, of trying to convince you that this is the right way to make decisions, but just to check coherence. Okay, so the newer part in this paper is doing the same exercise for the max-mean story. So just to motivate this, I'll go back here for a second. And here, this is maybe where Knight and Keynes come in. We ask a certain decision maker, be it a prime minister or a fund manager or something, and ask, what were you thinking? And we point out to them, say in this example here, that there is no Bayesian belief, there is no probability that can simultaneously justify assigning 0.4 to 10 and to 01. And then the person could say, maybe it's your prime minister who maybe spent, too much money on vaccinations, and maybe it's a fund manager. They could say, well, I couldn't really tell. It was a new event, and there was no rational way to come up with a single probability. So I was working with some range of probabilities in mind. And here we're going to use the max-mean expected utility model because it's relatively simple. In the max-mean expected utility model, you have a range of probabilities or some subset, convex, think of it as convex set of close set of probabilities. And for each act, you compute something which is the minimal expected utility. So the expected utility relative to each possible belief. And then you take the worst case as being sort of ambiguity averse, okay, trying to be on the safe side. So let's take this model for a second, and then the person can say, well, I had a range of probabilities which were between 0.4 and 0.6, and this is why both 0,1 and 1,0 are evaluated at 0.4. And, if anyone here has a better idea of how long the pandemic would last, God be with them, but, I didn't, and this is the way I made decisions, and I think this is even rational because there was no way to tell, okay? So this is what we want to allow in the second case. What we want to allow is to have the max mean. So now we allow justification not to be a single probability, but a range of probabilities. So we have a closed set of probabilities. Okay, so assume it's convex goes for free because we're taking a minimum. So without loss of generality, we could assume it's convex. And this is what the justification is now. Okay, so now the person can say, here were my possible beliefs, and for each act XA, I took the minimum possible expected payoff, and that's what I did. And it turns out that the existence of such a set is equivalent to something that's similar to what we had before, with two minor modifications. So we take real numbers that are here only non-negative. Okay, apart from 1. But if you forget about the 1 for a second, then it's as if we have half of the condition we had before. And in particular, we allow the certainty equivalent to be higher than the I mean, we don't want the certainty equivalent to be higher. Okay, so in this kind of graph, we could have the certainty equivalent above, but not the other way around. Because if you generate a combination of the x's that is above, we say, wait a minute, this doesn't work in the right direction. Because if you don't like uncertainty, and when you make decisions for others, you don't like uncertainty, one direction of deviation from Bayesianism is allowed, but not the other way around. Okay. And the extra thing that's allowed here is that one of these can be negative. Okay, so that's the result. The interpretation is sort of similar. We can think again of a debate game. The proof is a bit more involved, but also not terribly difficult. And there are two debates game, and only we change a little bit the rules of what does it mean for the decision maker to defend their choices. What does it mean for the skeptic to challenge them? Okay, some geometric interpretation that I guess I'll skip. And maybe now let me try to oversell this and why I think it's part of an important project. A lot of my life has been teaching in various audiences, particularly business schools. And I think there is some tendency of people in practice to say, we don't need decision theory, okay? Because you know, the kind of things that you could do in decision theory, I don't know how to solve. Or actually, you know what, there are two possibilities. One possibility is that you have all the data and you have great successes. Okay, so take, for instance, an application such as Waze to drive and find the shortest path. It's a great success, if you like, of the whole field, which mean decision theory, operations research, game theory, microeconomics. I'm not going to try to tell the difference between them, but overall, this is beautiful idea of rational choice, wonderful successes. They're coupled with statistics, and then you find some application like Waze where you tell me what you want to do, plus or minus, I'll get to point A to point B in the fastest way, or maybe some other shortest path or something like this. You can define the objective function. We have the map, we have the data, we can collect the stats, we have the algorithm to find out to find the shortest path. That's it. So it's a great success, but because it's such a great success, no one needs to study it. Because, you know, the students will tell you, fine, you know, we just have it on the app, so you studied it once and one programmer programmed it, and that's it. But then they say, this I don't need to study. The real problems that I have are not so clear. It's not so clear what the objective function is, not so clear what the probabilities are. It's not always amenable to statistical analysis. And often indeed, you know, when I teach and people would ask me questions such as, you know, what should I do with my money? What should I invest it in? I have to tell them, you know, the very fact that you have money to invest probably says that you know something I don't. You know, who am I to tell you what is a good investment and so on. So we readily admit that not everything is something that can be programmed as ways. And then there is a tendency to say, well, in that case, we don't need it at all, because this is where my intuition would shine. The same intuition that made me rich to have money, rich enough to have money to invest, is the intuition that would tell me what to do with this, and I don't need your theory. You could hear it from decision makers in politics, etc., that, you know, they made their way there and they're pretty confident and they trust their guts and they don't need us because we can only deal with formulas and things that fit into the model. And the conclusion that both of these have is that they don't need to study the theory. Now, as someone who makes a living out of teaching the theory, of course, it's against my interest. People believe they don't need it. But, you know, to the extent that I can tell that this is my belief, irrespective of my vested interest, I do believe that decision theory has a lot to contribute as a way of testing coherence of choices. Okay, so even when it cannot deliver the right solution, even when it's not a situation such as Waze or Google Maps where we have all the data and they can forget about the theory can help people at least avoid some of the mistakes, be these the mistakes that you have from the psychological theories of Kahneman and Tversky and their followers, or other kind of mistakes, you know, that have to do with things do not add up, or things like that. So overall, try to argue that there is a whole range of possibilities here between one extreme where, like the Waze app, that you ask a question, you put it on a computer, you get the answer, that's it. No point in arguing with the answer because this is the correct answer for your decision. There is the other extreme where you know, I won't be able to tell you what the right thing to do is, but I can try to take your decision, and a minute before you actually implement it, I'll try to sit down with you and say, well, let's see how we can justify it post hoc. So I'm not trying to replace your intuition, no way. But let us just go through the exercise and try to find out what are the beliefs and what are the utilities that could possibly justify it. And maybe in the process, you would find out some things that are more or less to your liking. In particular, you can find that the beliefs that justified are very extreme. You can find out that the utilities that you needed to explain, maybe they put weight on things you don't care about. Maybe it's driven by considerations of prestige that you thought you didn't, were not driving you, etc. So let's just sit here and try to find the simplest model that could justify your decision. Overall, there's an entire gamut in between them. So it's a whole spectrum of possible dialogues between the decision maker and the decision theorist. In one extreme, what we call the software is that you send a problem to the software, you get the answer, you don't argue. In the other extreme, it's like the shrink. You know what your decision is, and the decision theorist is like a therapist who's sitting with you and trying to help you understand yourself better. But there's a whole dialogue in between. And part of the point of what we do here, and the real novelty of that paper mathematically, is to say that the language of a dialogue is also part of the negotiation. So if you sit down with a decision maker and you ask them what kind of beliefs, what kind of probabilities could justify it, we should also be ready to get an answer that says, well, I don't know what the probabilities are, but maybe you don't know either. And maybe probabilities, a model with probabilities is just too stringent. It's not, I don't feel that I can express my true beliefs in a model with probabilities. And that's where the decision theorist should say, you know what, okay, here on the shelf there are a couple of other models. So let's try something else. And what we did here was to try maybe one of the simplest models that are non-Bayesian. And maybe the other or even simpler models. But the point is that the language of the dialogue, whether it is with probabilities or utilities or not, or something else, is also part of the dialogue. Okay, so the dialogue should be open to discuss the language of how do we use it, which model we use it, which is why I believe that we need more than one decision theory model in the world. Finally, and I had here some qualms when I heard Simon speak, but we have this, we're not the first decision theorist to quote Laplace here, but this is something that's been quoted around, and a quote that I find pretty nice. It depends, of course, how you interpret this, but he is talking about the supplement to the ignorance and feebleness of the human mind. But even when we're dealing with things that cannot be subjected to this calculus, the theory gives the surest insight. Now, I guess it depends on the interpretation, but we would like to interpret Laplace as saying, look, it's not necessarily the answer, but at least it can help you put some discipline on your decisions. And I apologize in advance if I'm reading too much into Laplace. And okay, it was a long time ago. Maybe he found room to be more optimistic than that. Generally, I believe that, and this is the crazy overselling, but I do believe that we have a role to play in society, not necessarily this paper, not necessarily us, but I think that this project of the Enlightenment should be ongoing. Okay, there is room for rational decision-making. If we're too strict with it as theorists, if we try to impose something that is a little bit too simple, then we might miss the audience. Okay? We should be open to the fact that not all of our mathematically elegant models would be acceptable or practicable for many people. But I don't think we should let decision theory be thrown out of the window when the classical beautiful models are too strict. I'll stop here.
Thank you, Itzhak, for that very interesting presentation.
Sorry, Sam, I missed this.
Thank you for the presentation. To kick off the questions, I suppose you've spoken quite a lot about decisions and understanding decision-making, but the other part of reasoning with probabilities usually involves learning and statistics and these things. do you see any natural way of taking these decision theories and incorporating that type of statistical learning, inferential logic in a non-Bayesian way as well from your framework and your perspective?
Okay, well, thanks. So yes, of course, the question of updating and statistics is very natural, and most of the non-Bayesian models that were developed also had the question of how do you update. Turned out to be rather thorny in the sense that, you know, Bayesian update is so pretty and there's so many different generalizations of this, even if you take a particular decision theoretic model. But yes, I mean, there are some results, there are some asymptotic results. Indeed, not always when we gather more information will we converge. There is this process called dilation where, I guess, you know, September 11 happens and then you find you thought you knew something and then you got some new information that put you in a sub-event in which you realize you know very little. But I think there's more to that. So in particular, there's learning from cases. There's a project that David Schmader and I have been doing for a couple of many years actually, of learning from cases without necessarily states of the world. So it's not a probability, but you just accumulate cases. Some of it turned out to be axiomatically approaching statistical techniques such as kernel estimation or maximum likelihood, sort of deriving it from axioms. Then there's other learning that goes on within these models that is, again, maybe non-Bayesian, in particular with David Schmeidler and Ofer Lieberman, also with Rossella Argenziano recently. We talk about learning the similarity function. So if I say, okay, we suppose we learn from cases, but what's the right way? So, okay, part of expertise is to figure out what's the right way. In some cases, such as medical cases, you could say, okay, you know, an experienced doctor knows whether they should look at blood pressure or something else. In some other cases, when you think about political debates, I think it's pretty open. People use different similarities, and it's not always obvious which is the right way to do it. And a lot of the debate is about that. But yes, I think this is part of the, you know, the plethora of models, if you like, of making decisions and of incorporating new information. By the way, with David Schmeidler and Larry Samuelson, we have actually a book about trying to unify case-based and rule-based reasoning and trying to focus. One thing that I find quite exciting is when do we switch? And this, again, Simon's talked about it a little bit, but you know, when do we get to a point from, say, the sun rose yesterday and before to say the sun always rises? And of course, with statistical counterparts of this, but even in this classical deterministic cases, I think it's quite fascinating. So yes, I mean, I think there's room for all of that, and some of this has been done and probably not enough.
Thanks. Philip Eisenhower, were you wanting to ask a question?
Oh, sorry. Yes, so thank you very much. I have a question regarding some thoughts on statistical decision theory allowing or enabling this dialogue between different stakeholders. And in our research, we're using kind of models to inform decision making. So put on restrictions on the state space, for example. And what I found very useful about using decision theory in this context is that if we are using these models for policy predictions, where there are, of course, competing interests, then statistical decision theory kind of allows us to decouple arguments about how the world works, about how to specify the correct model from the conclusions that we draw from it. Because it allows us to then think about how, even if we iterate on a model, we can still come to different conclusions without kind of arguing heavily about it. So I was wondering if there's any work related to these kinds of thoughts.
I do not know enough, and I'd be glad to see what it is, the work that you're referring to. If you could send me some references.
Yeah, sure.
Yeah, I don't, right now I can't think of anything that I can contribute, but it seems like you could share with me something I don't know about.
All right, I'll try to. Thank you very much.
Thank you. Yeah, so the question is, what about context? And I agree completely. And this is, for me, this is exactly the kind of thing that you would want to discuss in your model. Okay, so if I sit with you as a decision maker and I tell you, look, you made some completely incoherent decisions, and you know the voters are going to nail you. It's terrible what you've done. And you say, no, it was in a different context. And I say, you know what? Okay, maybe we should put the context in. And by the way, I think this is a general question about rationality. Even if you take Kahneman-Tversky framing effects, I don't think it's so easy to define what they are. I think eventually the definition of a frame is subjective. Okay, so what do I mean by that? You could say, well, and I've heard maybe for the first time from my then colleague Ehud Kalai, who said, what's this story about the frame? If your doctor decided to give you the probabilities in terms of death or in terms of survival, the very fact that it shows this language is indicative, right? I mean, so if your doctor chose to say, there's a half, or the chance of death is half a percent, or if they say 99.5% that you're going to survive, why did they choose this particular thing? So if you try to define framing as, the representation that doesn't really matter, or to say that framing effect, sometimes I use it in class to say it's the kind of thing that disappears once you use a formal model, then the question is, what is a formal model? Because someone can put in the representation in and say the very fact that someone chose to represent it this way is informative in and of itself. In the Monty Hall example, we talk about it all the time. We use it in class, a three-door paradox, to show that who gave you the information matters, and sometimes they have incentives, sometimes. Along the same lines, I would say here, context matters. You want to bring it in, okay, fine. Let's put it into the story. And you will also have to explain why you chose or why you let context interfere in your decisions, right?
And then for the certainty equivalence, CA, it already makes a big difference whether you see that equivalence as an equivalent gift or as a price to pay. And that might give a big difference in your analysis and interpretation as well, I think.
Absolutely. Yeah, so this model implicitly assumes that doesn't matter, but if you say, no, it does, because we learned from Kahneman-Tversky that the willingness to pay, etc., and the equivalent gift are different things, and we have endowment effect, etc., fine. And then you'll have to say, I, as the decision maker who made decisions for you, I took the endowment effect into account because I think it's important. It's up to you to decide whether or not you want to do it. Now, in some cases, it won't be a problem. But if you tell your children why you were willing to pay so much for, I don't know, a family heirloom or something like this, I don't think you'd be considered irrational. Right? I mean, some cases of the endowment effects are easier to defend than others, but I mean, this is for me exactly a case where you want to take the language of the model to be a subject of discussion as well.
I agree. And for me, it's important that if you talk about gifts, it makes you inward looking how you appreciate it. If you think in terms of deals, it makes you much more alert on who is providing the deal and why, and so on. But okay, thank you for your answer.
Thank you.